All right, folks, I'm going to get started here. Welcome back, everybody. Welcome back to Macroeconomics, Introductory Macroeconomics, Econ 161, the second week, the second meeting of like roughly 16, I think, is how many times we'll meet overall throughout the semester. So congratulations on making it through the first week of school. That's always kind of like a big benchmark. You never know what you're going to get, and then you do, and then hopefully it works out. So far for me, it's been working out. Sometimes you enter a semester and you encounter like that one student that you never wanted in your class. you know, just from day one, it's like no, I can't deal with this now. But generally that's a very extreme case, and most people do not fall into that category, and it's been pleasant all around. Meeting all of you, meeting everybody in all my other classes, things bode well for the rest of the semester, fortunately. So today we are going to cover. I didn't do an agenda for today. We're going to cover both chapter 2 and chapter 3. So again, at the beginning of this course, it's very much like whatever. If you've taken a micro course, it's pretty much that course. The first 2 weeks, because we're introducing the basic concepts, the basic principles that underlie all of economic theory. And then today, chapter 2 deals with like the introduction of what a model is and like some samples of models that we use. Like we kind of go through them in depthly to understand how they work, so that you understand how they work. And then we'll finally, after taking a break, go into chapter 3, cover that, and that will cover the most important model that we cover in this class, which is like the supply and demand model, something that if you haven't taken economics at the college level, you've been introduced to in college or high school at some point. Or it's like the one thing they teach everywhere all the time. So a lot of what you'll see is familiar. Some stuff will be foreign to you, but overall, like it should be a comfortable day for you. Now, as far as like some housekeeping. So as far as like the wait list, all that stuff, so the wait list is over, right? So that the wait list no longer applies. But what I did is I did take note of everybody's place on the wait list. So if you were on the wait list, then you will still have that priority with me in terms of like being able to be let into the course. And so I've got numbers next to your name on the list, and that will dictate like the order in which I will let people in, given spots opening up. Now, spots have not been opening up, so people have not been let into the course. So it's not looking too good, folks. People that are trying to get into this course, it's not looking too good. I still have, let me see, it's like 3, 4, 5, 6, like 8 people that are trying to get into this course based on my list. I have 6 of them that are on the list, that were on the waiting list. So Jocelyn Villacorta, are you here? Okay, so we already spoke today. Okay, so you will be let into the course. And then Daisy Abrenica, so you're number 2. So it's likely you'll get into the course. And then beyond that, I've got Nadia, number 3, Sarah Rodriguez, number 4, Eric Morales, number 5, Christina Manukian, number 6, and then I have 2 people that weren't on the list, Melesio Juarez and Ismael Gomez, and both of these people, the last 2 that I mentioned, like I'd have to lottery off a spot for you, but that's given that 6 other people dropped the class. So it's just to keep in mind that that's the place you're at, and who knows what could happen? Maybe a bunch of people will drop in the next 2 weeks, maybe not, But again, the only way you can have even the option to get into this course is by coming to the lectures and being here the entire period. So if you want to continue trying to get into this course, I will have you sign into the sheet at the very end of the day, not in the middle of it, and that again is going to show me that you are dedicated to trying to be in the course. But as far as me letting people into the course, I can only let people into the course that the room allows for. And even though there are going to be open seats here because people aren't going to show up on exam days, everybody's going to show up, and that's what the university's thinking about, and that's why that limit exists. And there's nothing I can do about it. I can't take any personal circumstance into consideration because that would be unfair to other people. Everybody's got a story. Everybody's story is valid, and therefore everybody's valid story cancels out, and all that's left is like my fair system that is going to either let you in or not, given the circumstances. So again, everybody's free to do whatever you want with respect to this, as far as like either waiting and trying to continue coming into the course or not. You're free to do whatever you'd like in that respect. But again, it's a risk and a gamble, and you're free to take it. And that's all I'm going to say about that now. And we can talk more about it individually at the end of the course for whomever would like to discuss any issues related to that. But that's like something I needed to talk about for a second. Okay. Are there any questions about anything relating to the course, not relating to getting into the course, but like how the course runs and things of that sort? Yes. Okay, so did you get my email that I sent last week? Well, let's do a little bit past that. If I didn't give, well, I'll extend the deadline if it's a problem for anybody. But yeah, go ahead. Right, but you know that there is that free trial that you could get on Launchpad for 3 weeks that gives you access to both the digital book and the homework system. Yeah, so that's one of the options that I covered the first day in terms of like being able to register for Launchpad and not having the book option initially. Like, so yeah, so that's an option. So you can just register for that, and then once you actually do get the book, I explained the first day how you just go about like actually registering for the course once you have the book. So just really quick, just to cover this one more time, like the bookstore ordered the wrong book. Some of you bought the book. Nobody had problems returning your book, right? Because I know some of you opened the book, but I made sure that it was okay to return them even if they had been opened. Okay, and so what's going to happen with that is they've reordered the book, and they should get it next week at some point, as far as what I've been told. So if you're looking for the hard copy of the book, it's going to be available at the bookstore. But if you're looking for just a digital copy and just a digital system to do the homework, which is what you need, that's available to you now. So you can just go through the Launchpad link on the digital syllabus, and that should get you access to it, and it should be fine. Other questions regarding this or anything else related to the class? Yeah. I don't know if we're the only class, but we might be. I don't know for sure. Yeah, but the bookstore would have told me if other professors had it, but actually no, they might not, because then that class would be kind of screwed because they wouldn't have books. So, but again, like it's not a big priority because things aren't going to be due, and you can have the free trial period, and you can also just buy like a cheap hard copy online if you don't necessarily want a brand new book. But again, the benefit of the new book is that at the end of the semester you can sell it back and get a little bit of money back. So that's the benefit of getting the new book. Other questions? Alrighty. All right. So if there are no other questions relating to anything with respect to like how the course runs or stuff that might come up, I'm just going to get going with the material. All right. So let me see. What time is it? It's 7:08. So again, we'll take a break once I'm done with this chapter, and then that'll be about 15, 20 minutes, and then we'll jump back into the next chapter, cover that, and that'll be the day. It'll be over before you know it. Alrighty. So today we are, like I said, covering chapter 2 first, economic models, trade-offs, and trade. So what you'll learn in this chapter is why models play a crucial role in economics. Two simple important models, the production possibility frontier and comparative advantage. Now again, these are models that are covered at the beginning of all introductory courses, so you may actually have already been exposed to these models, so that's a good thing. The circular flow diagram is something else we will cover, which is like a schematic representation of the economy, and it's the one we'll look at is simple. We'll look at a more complicated one later in the semester when we open up the economy and actually get to what this course is about, which is like macroeconomics. But again, it's about introducing you to these basic concepts that are super important in economics. So we'll talk about also the difference between positive and normative economics, which is an important distinction. It's the difference between like making observations that are just clear cut based on what you see versus making observations and then trying to impose like your value on what you see. Meaning like, I see this amount of wage and that's a bad thing versus like this is the wage and this is how many people are employed at that wage. So I'll talk more about that when we get to it. When economists agree and why they sometimes disagree. So again, models are simplified versions of reality. You make a lot of assumptions about what aspects of reality are simple in order to gain some insights from the model. And sometimes people disagree about those simplifications. Well, you got this conclusion based on this simplification that's not realistic. Therefore, your conclusion is invalid, that sort of thing. So let's talk about models in economics, some important examples, these two models that we're going to look at. So just a model, formally defined, is a simplified representation of a real situation that's used to better understand real life situations. So like I mentioned last time, the world is complicated, the economy is complicated because at the heart of it is all of us, individuals, fickle. One day we're thinking we're going to do one thing, the next day we do something else. Sometimes it doesn't make sense, sometimes it does, but if you aggregate, combine everybody's behavior, it can become a little bit chaotic. So scientists who study the universe have models. You've probably seen models of the solar system. You may also have seen models of the atom or the DNA double helix. So models are also used by economics to better understand reality. Economic models attempt to simulate the workings of the economy. A model's simplicity allows economists to study the effects of changing just one part of the model. So that's where the simplifications become important. They allow us to then just focus on one thing and sort of try to make some inference about that one thing, something, gain some insight that otherwise you may not be able to. Now, again, because it's based on a bunch of assumptions that simplify the world, the inference you make may not be considered valid by a bunch of people, and that's where like contention comes in and people are debate and whatnot. So every other part of the model, when you're trying to simplify in order to focus on one thing, is held constant. So you're trying to like control some chaos in order to create some clarity about something. And again, that can be a problem. So I forgot to delete that first slide. Okay, that was a duplicate. All right. So an important assumption when building economic models is that other things are equal. This assumption that you are holding things constant. This other things are equal assumption, formally defined, means that all other relevant factors remain unchanged. In Latin, it's called ceteris paribus. It's just a Latin way of saying holding all else constant. So we try to keep economics as close to a laboratory science as possible, with only one variable allowed to change at a time. And again, like this all goes back to like that distinction I made last time with respect to like economics as a social science versus like a natural science, where in natural science you can sort of have like laboratory experiments and like control everything and like actually get to conclusions that are valid that can help you predict how the natural world actually behaves. Whereas in economics, it's weird to say, well, I have this laboratory and I'm doing this economic experiment within it. Like, what does that mean? Like, are you like experimenting with an entire country? Are you experimenting with like this population of people that are unaware of it? Like, what does that mean? So you can't always find or create a small scale version of the whole economy. For many purposes in economics, the most effective form of economic modeling is the construction of just a thought experiment. So these are simplified hypothetical versions of real life situations. So really just like thinking through like what are the variables, and then sometimes you can try to find like a natural experiment in the world where you might have like maybe two societies that like mirror each other pretty closely, but like one society has like maybe socialized healthcare and the other one doesn't. And we can say, well, what is that? How does that affect like employment or not? Like things like that do occur in the world, but they are rare, and even when they do occur, they can still be a little bit more complicated than we'd like them to be. So, for example, an economist might consider a consumer who's buying CDs and ask, what would happen if the price of CDs fell? So economists use the model of consumer demand, which allows the price of a product to change, and then consider what happens as a result to answer the question. So the simple thought experiment held some important factors constant. So there's other goods in the world that people consider besides CDs. So the price of these other goods didn't change either. Um, so the example shows that it's often possible to describe and analyze a useful economic model in plain English to tell a story. Um, so because much of economics involves changes in numerical values, using some mathematics helps to clarify an issue. So if you've taken any economics before, you've seen um, some graphs that represent some of these models that we talk about. And so there's different ways of representing these models. So the first very simple way is just to describe a model, and then maybe just to create an argument just with words and like sentences. That's like the basic approach, and that's an approach that was taken for a while. If you look back to 1776 when Adam Smith sort of created microeconomics with the Wealth of Nations, that's all words. There's no math in there. It's just like description of like what people do in markets and how people produce and how that's efficient and blah, blah, blah. A lot of words, a lot of explanation. And, that's one way of sort of approaching this discipline and trying to get some sort of worthwhile results. But then another way is to like represent some of these relationships with equations, and then those equations can be represented graphically. So that's a geometric representation of a model. And then, of course, those representations have limitations because anytime you're representing something in a graph, you're only showing the relationship between like two variables, like one that's dependent on the independent variable. And although that can provide us some useful insights, it's still limiting because obviously in the world, like more than just one variable acts on another variable. So if we're talking about like the quantity demanded of CDs, like it's not just the price of the CD that acts on it. It's like the price of the related goods that act on it. It's the income that that somebody earns that then affects how much they buy. It's the amount of advertising they've been exposed to. So there's a bunch of other variables. So whenever you have those kind of like multivariable relationships, where you have one variable dependent on the behavior of a lot of other variables, then you can't represent that geometrically because, again, you're talking about like 2 dimensions on a flat surface. Maybe you can get 3 dimensions by doing like a 3-dimensional representation that gets a little muddy as far as like what it means. And then beyond that, you can't do it. Like you can't represent 4 dimensions. Like it's not possible. What you could say is you could take a 3rd-dimensional representation. Then you can say, well, that's moving across time, which is another variable that could be affecting stuff. And then you can change what you see, and that would be a representation of like a 4-dimensional relationship. But that's it as far as it goes. And even there, it gets complicated and difficult to understand. So again, there's different ways of sort of approaching economic analysis. And in the introductory level, we focus mainly on just using like words and like graphs and some math, but keeping it very simple. That again, reflecting the simple nature of what we can represent with graphs. And then when you get beyond that, like I teach price theory, which is intermediate microeconomics, and also management economics, which is like a weird sort of version of that for management students or business majors. There we get into a little bit more of the complicated cases, but even there we don't go too far because, again, like you need more sophisticated math to be able to understand like multidimensional, multivariable relationships, and then beyond that it just gets nuts. And that's, when at the graduate level and beyond, it's like you better know a bunch of very sophisticated math or else you don't know what you're talking about, and nobody will let you into a program unless you take a bunch of really advanced math. And if you're ever interested in finding out what classes you should take in terms of math, come talk to me and I'll tell you exactly what you should be taking in order to get into a grad school program in economics. All right, so again, a numerical example can be represented with a simple equation or a graph and can be key to understanding an economic concept. All right, let's move on from there. I didn't order these properly. Sorry about that. All right, so we'll consider 3 important models used by economists to explore this point further. So the first one is going to be called the production possibility frontier, and it's exactly what the name would suggest. It's a model that tells us how much can be produced in a very simplified economy that we'll be looking at. So again, it helps economists think about trade-offs that every economy makes whenever they're thinking about how much to produce. Like in order to produce one thing, you have to produce less of something else. We'll also look at the comparative advantage model, a model that clarifies the principle of gains from trade. Remember, that's one of the principles from the last chapter that basically said that if people trade with each other, then they can create more benefit than if they just try to produce everything on their own. So trade between individuals and between countries can be sort of analyzed with this comparative advantage model. That goes back to like the 18th century. This guy, David Ricardo, came up with it. And the circular flow diagram is something we'll also look at. Again, a schematic representation that helps us understand how flows of money, goods, and services are channeled through the economy. So in discussing these models, we make considerable use of graphs to represent mathematical relationships. Graphs will play an important role throughout this course. If you're not already familiar with how graphs are used, you should carefully read the appendix in Chapter 2. It just kind of goes through all the various characteristics of a graph and how they work and how you can understand them, because again, we are going to be using be using graphs quite a bit in this course, and ultimately what we're going to be doing a lot of as we get further in the course is like having multiple graphs, multiple curves on one graph. So you'll even see that in the demand and supply model. And so if you're not comfortable with graphs and how they work and all this stuff, then it's going to be a difficult time for you in this class. So the best thing to do now at the beginning of the semester, when you have some extra time, is to spend some extra time to just get familiar with things that you probably learned at some point in your life, but might be a little sketchy at this point. So you just want to kind of refresh your memory of like what you maybe forgot. And I'm sure the majority of you don't need to do that, but you might want to check out the appendix just in case there's one or two things in there that you are, a little shaky on. All right, so let's get into this one model first, the production possibility frontier. So the first principle of economics introduced in Chapter 1 is that resources are scarce, and as a result, economies face trade-offs. So this production possibility frontier illustrates the trade-offs facing an economy that produces only two goods. It shows the maximum quantity of one good that can be produced for any given quantity of the other good. So the PPF is just sort of the simplified acronym to represent the production possibility frontier. The PPF is a diagram, much like you see here, that shows the combinations of the two goods that are possible for a society to produce at full employment. So what's meant by full employment is that it's utilizing all its inputs to produce. So there isn't like unemployment related to like ups and downs of the economy. Everything that can be produced is being produced, given the limitations of scarce resources. So in this world that this model represents, and that's always an important thing to do, is like kind of put yourself in the simplified world of the model in order to kind of think within it, so you don't try to complicate the world and bring other knowledge into it, intuition that you have built up throughout your life about certain things, because then that could really get in the way of you just understanding the very simple stuff we're trying to highlight with these simple models. That's always one of the big pitfalls in these courses, is like people try to bring in what they know about the world into what they're studying. And there's nothing wrong with having your own knowledge about things and understanding that the world is more complicated than what we're doing. But you also have to be willing to sort of allow in the simplicity of a model and think within it in order to just, again, understand like the simple insights we're trying to give you from the simple model. All right, so in this model, in this simplified world that we are living in within this model, only coconuts and fish can be produced. That's it. So there's a trade-off between coconuts and fish. You can produce only coconuts, and if you do, then you can't produce any fish, and vice versa. We'll look more at this in a second. So we can use the PPF model to answer questions like, how much can we produce? What will it cost to change our mix of production? Does it make sense to import the good from somewhere else? All right, so let's look at a simple version of the PPF. Here, still within this simple world where only coconuts and fish are produced. So the model, again, simplifies reality by looking at just one economy and assuming that it can produce different amounts of just two goods. So the model assumes that the economy has a given amount of resources with which to work. We assume that when we're just looking at a production possibility frontier that isn't changing, that those resources aren't changing. So this amount of coconuts and fish that could be produced by this economy is a direct result of how many resources there are, and that isn't changing for now. It also assumes a given level of technology. So the productive capacity of the economy is fixed as well. So the amount it uses to produce is fixed. So the amount of people and machines and all this stuff, it's fixed. It's not changing. And then also the level of technology that you have to produce is not changing either. So it's not evolving. You can't get more efficient at producing while you're just like kind of living in this simplified world, unless we say that that's going to happen. So based on these two very simple assumptions, the economy can produce a number of different combinations of these two goods, coconuts and fish. So the number 30 here represents the quantity of coconuts that the economy can produce if it used all of its resources on coconut production. So it is just mathematically the y-intercept for the production possibility frontier line. So it hits the y-axis. Remember, this is the Cartesian plane. It's the standard plane where you draw graphs, where you've got a y-axis and an x-axis. And the x-axis generally represents the independent variable, and the y-axis generally represents the dependent variable. But we're not thinking about that kind of functional relationship right now. But as far as just like the significance of this number, it is what it always is whenever you have a line on a graph. It's the y-intercept. And in this case, the y-intercept represents the most amount of coconuts that you can produce if you only produce coconuts in this simple world where only coconuts and fish are produced. Similarly, the 40 down here is the x-intercept, right? This is the x-axis, so this is the x-intercept for the production possibility frontier, and it represents the most amount of just fish that can be produced if you produce only fish in this economy. So if you produce no coconuts in the economy, then you can produce 40 fish by using all your productive capacity to produce fish. And of course, if the economy wanted to produce both of these goods, some coconuts and some fish, then you could produce in combinations like you see here at points A and point B on the production possibility frontier, where point A represents a combination of making 15 coconuts and 20 fish, and point B represents a combination of making 9 coconuts and 28 fish. So all of the combinations, besides these two, which are all along the production possibility frontier, which make up the production possibility frontier, are points on the production possibility frontier, so the economy is using all its productive resources. So if we are on this line, then everything that can be used to produce is being used, and that's the most you can produce of the two goods at any given point. So then the question is, where do the trade-offs come in? So suppose the economy is producing at the point where you're making only coconuts, you're only producing coconuts, and everybody's like, we're tired of coconuts, we want fish. So to produce fish, resources must be moved from coconut production to fish production. So starting from 30 coconuts, let's say if you wanted to produce 20 fish, you must trade off the production of 15 coconuts. So going from this x-intercept here, this point of just producing coconuts, if you want to produce, let's say, 20 fish, then you're going to move from that point along the production possibility frontier to point A, and that means that you are going to give up 15 coconuts, and you're going to wind up just producing 15 coconuts, whereas before you were producing 30. And now you can produce 20 fish. So in this case, and in any case, when you're sort of moving along the production possibility frontier and trading off, you are essentially incurring an opportunity cost. So again, the opportunity cost, the concept defined last time, is what you must give up in order to get something. So in order to get the 20 coconuts, you had a opportunity cost of 20 fish, you had an opportunity cost of 15 coconuts. So every point on the PPF has one thing in common, and that's efficiency. So since you can only produce more of one good by producing less of the other, there are no missed opportunities. So that's what we mean by efficiency in this case. If an economy is producing at any point on its production possibility frontier, we say the economy is efficient in production. That's what we're talking about here specifically, production. Now, let's say we are on some point within the production possibility frontier. And again, it's all about understanding the model and the world in which you're working. So that's what we're doing. We're just kind of highlighting all the various characteristics of this very simple world that we've established in this simplified model. So you could potentially be producing at some point like C, where you are inside the production possibility frontier. Now, when you're doing that, you are essentially at a point where you can produce whatever it is you're producing. So it's called feasible. It's doable, it's feasible, but it's not efficient. You could be producing more of either good by moving up to the production possibility frontier. So again, the economy could produce C, meaning that it's feasible, but the economy could do better than C. The combination at C is not efficient. So you're only efficient in production when you're producing on the production possibility frontier. So again, all points under the curve are feasible but not efficient. All points above the curve, so any point outside the production possibility frontier, is not feasible. We can't produce, this amount of coconuts and fish given our technology and our productive resources. And all points on the curve are feasible. We can produce those, and they are efficient in production. But that's not the whole story about efficiency. The economy also has to be efficient in allocation, meaning that everybody has to get what they want as far as what's being produced. So again, this means that out of all the combinations on the PPF, it has to choose the one that makes consumers as well off as possible. People have preferences. Do they want coconuts? Do they want fish? How much of each do they want? So efficiency overall for the economy as a whole requires both efficiency in production and efficiency in allocation. But within the production possibility frontier, as it stands, we're only talking about efficiency in production. We're not talking about who's getting the goods and which combination people prefer the most. We're not talking about that yet. So to be efficient, an economy must produce as much of each good as it can, given the production of other goods, and it must also produce the mix of goods that people want to consume. So the last assumption made here is that the PPF is a straight line. So that you saw that first example where it wasn't a straight line, it was kind of curved out. So that has some meaning. So in this case, whenever you have a straight line on a graph, that means that you have a constant slope. So that the change in y with respect to the change in x, so the rise over the run, is constant along this line. But if the line, if the curve is kind of curved out for whatever reason, then that means that the slope is changing as you move along it. So the slope of a production possibility frontier captures the opportunity cost at any given point of producing one good versus another. So if the slope is constant, then this means that the opportunity cost for fish and vice versa, opportunity cost of coconut for fish, is the same regardless of the point of efficient production. So as we move along, as you're increasing the amount of fish that you're producing, you're giving up per unit of fish the same amount of coconuts no matter where you're at. So going from point C, in this case point C is up here, the intercept, point A to point A, as we did earlier, the opportunity cost of 20 fish is going to be 15 coconuts, as we said. So you're going to have, as far as mathematically, how do we figure that out? Well, how you figure it out is you think, okay, I'm looking for the opportunity cost of fish, let's say. So the opportunity cost of fish is going to be in coconuts. So in order to figure out what that opportunity cost is, you're going to set up a ratio of the two numbers. So the question is, let's say, what is the opportunity cost of 20 fish? And so that cost is going to be in coconuts. So therefore, the coconut value, which you're giving up, which is 15 in order to get the 20 fish, is going to be on the numerator. and the amount of the good you're thinking about, as far as like what its opportunity cost is going to be on the denominator of this ratio. So numerator is the top number, denominator is the bottom number of a ratio. So again, we're trying to figure out what the opportunity cost of fish is along this production possibility frontier. That's a straight line, therefore the opportunity cost is constant. We know it's 15 over 20 when you're increasing the quantity of fish by 20 and decreasing the quantity of coconuts by 15, but we can simplify that. We know there's a common factor in there of 5. 5 goes into 15 3 times, 5 goes into 20 4 times, and so therefore the opportunity cost of fish all along the production possibility frontier is just going to be 3/4 of a coconut. So that's what this is telling us. So anywhere along this production possibility frontier, anytime you want to increase the amount of fish you're producing by 1 unit, you got to give up 3/4 of a coconut in order to create that one fish, given your resources and your technology. So 3/4 is equal to 0.75. And we can look at it from the opposite perspective as well. What is the opportunity cost of fish? So let's say that we're trying to figure out what is the opportunity cost of going from 20 to 8. Actually, this is not from the opposite perspective. This is the same thing, but we're just moving along the production possibility frontier, and I'm just trying to highlight here that the trade-off doesn't change. The opportunity cost is not changing. So in order to go from point A to point B, where at point A we're producing 15 coconuts and 20 fish, at point B we're going to increase our fish consumption by 8, production by 8, and we are going to decrease our production of coconuts by another 6. So again, we're trying to figure out the opportunity cost of fish. So to produce 8 fish, we're going to give up 6 coconuts. Our opportunity cost will be in coconuts, so coconuts will be on the numerator. And again, that's got a common factor of 2. 2 goes into 6 3 times. 2 goes into 8 4 times. So that simplifies down to 3/4, which is again 0.75, which again just highlights that the opportunity cost of producing one more fish is always going to be 0.75 coconuts, no matter where you're at on the production possibility frontier, if it's got a constant slope and therefore just a line. So in reality, though, things are a little bit more complicated. So economists believe that opportunity costs are actually increasing as you increase the amount of a good that you're producing. And that's because initially, let's say you have a certain amount of fish that you want to create, and you've got a certain amount of like machinery and people that are available to fish and ultimately produce fish, right? And that's great. But let's say the economy then is like, we want more fish, and screw coconuts. Coconuts suck. We want a lot of fish. Well, now you have to use what you have in order to create more fish, and what you have maybe is not suited for fish production. Maybe it's just suited for coconut production. Like people then that were producing coconuts have to be retrained, and they have to learn how to fish. And machines that were meant to help sort of refine the coconut into whatever it is that makes it palatable as far as like consumption, that machinery now needs to be repurposed to maybe clean fish or whatever it is that you do to produce fish. And so as you are increasing the amount of fish that you are consuming, the opportunity cost in coconuts is actually increasing. And that again reflects that sort of more realistic aspect of reality, that when you're trying to reallocate productive resources, some of them aren't going to work as well as like those that are meant to do whatever you're intending them to do. So the PPF therefore is not a straight line but a curve, as you see here. It's bowed out away from the origin. It's also called concave when it looks like this. So initially, let's say we are at the intercept again from this curve, meaning that if we use all of our productive resources, we can produce 30 coconuts. But then, we're like, we want some fish. Coconuts are boring. So producing the first 20 fish means that you're giving up 5 coconuts. And that's not too bad, given that, you've got some resources that you can finally dedicate to fish production that were just sitting around being used for coconut production. So in this case, the opportunity cost of fish, again, just to just to get that number down, is going to be a ratio, and the numerator is going to be the amount of coconuts that you are giving up, because the opportunity cost of fish is in coconuts. So we're giving up 5 coconuts to get 20 fish. So therefore, the opportunity cost along this range here from 0 to 20 fish is going to be 1/4 coconut. So initially, as I'm deciding to finally start producing fish in this weird economy where I only produce coconuts, I am giving up 1/4 of a coconut per fish that I produce. As people start to become more dependent on fish, fish can be good, so people like fish and maybe want more. That means that you have to start using some of your resources to produce more fish. In that case, to produce the next 20 units of fish, we're going to have to give up a lot more coconuts. So again, as far as like the math goes, so again, you're measuring the opportunity cost of fish in coconuts, so that's going to be the numerator, the amount of coconuts you're giving up. You're giving up 25 coconuts in this case, going from this point to this point. Here you were producing 25 coconuts and 20 fish, and now you're moving down to this point where you're only producing fish and 0 coconuts. So that means you're giving up 25 coconuts. So that's what your cost is, your opportunity cost of fish. It's going to be in coconuts. So that's the numerator, 25, to make 20 more fish. Now we've got a common factor of 5. 5 goes into 25 5 times. 5 goes into 24 times. So you wind up with 5/4, which is also equal to 1.25. So what this tells us is that the opportunity cost of producing fish in terms of coconuts has increased by a large factor here, a factor of 5 in this case. And again, and that's simply because we are now showing our production possibility frontier as a curve that kind of bows out from the origin rather than just a line. So just that small change has been able to capture a part of reality that's a little bit more realistic than, initially. And again, this is all meant to like introduce you to like this concept of like using simple models to explain reality and then like changing them slightly to maybe explain it a little bit more, to capture a little bit more complexity in the world. But definitely I need you to understand how this model works, and I need you to make these kind of computations and understand how you get these numbers and what they mean and all that. So again, like I mentioned last time, this class, it's about like understanding the tools and the concepts and then like applying them. So it's kind of like a weird math course that's kind of mixed in with like a course where there's a lot of like theory that's like descriptive. So that's how you should be thinking about it. Don't be memorizing every single thing on every single slide. It's about just having that understanding of like what it is that we're doing, the tools we're working with, what they mean, how you measure things, being able to demonstrate that. That's ultimately what you're going to need to do in this class. Understand the terms. That's going to be reflected in like multiple choice type of questions, and there's going to be a few open answer questions that might require simple computations like you see here. So just keep that in mind. I'll have a practice exam up. Like I said, I'm trying to get it done this week, but things have been kind of hectic, so I'll probably get it done next week. But still, you will have a practice exam before the first exam, so you'll have like a guide as far as like how you should be thinking about this stuff and how you'll be tested. All right, so anyway, so that, again, represents how the production possibility frontier works, how it can be a little bit more complicated by just changing the small sort of feature of it. Yes? It won't matter. That won't matter. I'm just going to be looking for you to show me that you understand what you're doing. Simple things like that will never like affect you adversely. I will never take points away for silly things like that. Yeah. Just that you know what you're doing, Yeah. Right, exactly. If we are producing on the line, even though our opportunity cost is increasing because we're moving along it, if we're producing on the line, we are producing efficiently because we're using all our productive resources to produce that combination. But great question. All right, so the PPF can also be used to demonstrate the concept of economic growth. So we talked about economic growth last time, like the increased capacity of the economy to produce and how that has changed our lives dramatically over the last 100 years. Where, I talked about how like people 100 years ago, didn't have toilets, didn't have electricity, didn't have everything that we have today. We're so lucky to be alive today, but for a lot more reasons than that. But nonetheless, like it is economic growth that resulted directly from like these big technological revolutions that occurred like in the 18th century, in the 19th century, now with this digital revolution that have dramatically changed our lives. And that, again, is a direct result of our increased capacity to produce. Like before, people used to just pick cotton from the fields, took forever. Then the cotton gin was created, and that just allowed us to mechanize that process of like picking cotton or whatever. And of course, that per minute, per hour, whatever, like just exponentially increased how much cotton we could produce. So that's what I'm talking about here. So the PPF can also be used to demonstrate this concept of economic growth. Economic growth, again, formally defined, is an increase in what the economy can produce. So if the economy can produce more, then what's going to happen is the PPF is going to shift out. So the economy can now produce more of everything in this new PPF. So this is the original PPF. And what's changed is likely our technology. Now we can produce more per man hour, per person hour. And that has allowed us to, as opposed to before, maybe only being able to produce 25 coconuts with producing 20 fish. Now we can, if we go up to the new PPF, we can still produce 20 fish and maybe produce, like here it looks like maybe 33-ish coconuts. So we can, in terms of like, these combinations, they've all increased because of our ability to produce more. And again, like just shifting the production possibility frontier will capture that small, very important result. Yes. It can be also, the other big one we consider here is like our inputs. So if like the population has grown and the labor is more, then yes. If our machines have increased, then that will also do. Yeah. So those are the two big factors we're considering here. So again, comparing points A and E, it's clear that there's more of both goods being produced. So we say the PPF has shifted outward, increasing the possible production of both goods. All right, so these are essentially two sources of economic growth, as I just mentioned. One is the increase in the economy's factors of production. The factors of production are resources used to produce goods and services. Economists usually refer to the term factor of production to refer to a resource that's not used up in production. So land is a resource provided by nature. So all the natural resources are generally put under this like category of land. Labor, us, people, workers, is the economy's pool of workers. Physical capital refers to like machines and buildings, things used to produce. Human capital refers to the educational achievements and skills of the labor force. So all of you are currently accumulating your human capital by just being here. All right, so that's one of the factors that increases the economy's ability to produce, and the other one is, of course, the technological progress that I mentioned. So technology, again, is the means for the production of goods and services, and if that improves, then you can produce more at any given level of a good. All right, so understanding the production possibility curve is essential for understanding the next model of comparative advantage. So now we're jumping to the second model. So that's it for the production possibility frontier, but we are going to use it here to understand comparative advantage. But again, like I'm introducing you to the concept of models. We're going to be using models throughout this course. They're going to be more complicated than what you saw, but the process of understanding them is going to be the same. Like we're going to look at them, we're going to talk about them, the various characteristics of them. We're going to look at, when things change within them. We're going to look at, factors that might affect them from the outside that maybe, cause the entire relationships to change and look different. So this is how you should be thinking in this course, is just like understanding the models, understanding how they work, and understanding the significance of, how they're set up and the insights that we can gain from them. All right, so again, understanding the production possibility curve is essential for understanding the next model of comparative advantage. The comparative advantage model considers two producers, each of which produces the same good, let's say. In this model, we compare the two production possibility frontiers to see which producer can produce which good cheaper. And by cheaper, we mean they have a lower opportunity cost than the other. So the philosophical result of the idea of comparative advantage is that it makes sense to produce the things you're especially good at producing and buy everything else from everybody else. So a country might have a comparative advantage in producing a good or service if its opportunity cost of producing the good or service is lower than other countries' opportunity cost in producing that same good or service. Likewise, an individual, like you or I, has a comparative advantage in producing a good or service if his or her opportunity cost of producing the good or service is lower than for other people. So we'll explore these ideas further with an example that should highlight, again, how the model works and how you can identify who has a comparative advantage and who should be making what. So suppose if there's two countries, one country is named Krugmania and the other one is named Welsia, and they can produce only two goods, apples or pantyhose. That's it. That's all you can produce. So if Krugmania only produces apples, they can make 100 units of apples. If they only produce pantyhose, then they can make 150 units of pantyhose. So what do these numbers mean in terms of like Krugmania and their production possibility frontier? I'm just wondering what these numbers mean with respect to like their individual production possibility frontier. Like, just think about the numbers that I highlighted in the production possibility frontier that I showed you initially. Not exactly. The maximum amount of production of either one good or another, which graphically, what does that? Where do those numbers lie? On the intercepts, right? On the intercepts, yeah. Okay, so that's what I'm talking about. That's the information that we're being given here. We're being given the intercepts for this production possibility frontier. We're being told if they only produce one good, this is how much they can produce. If they only produce the other good, this is how much they can produce. And that graphically just is the intercepts for the production possibility frontier. Now for Welsia, the other country, that country, if it only produces apples, can produce 300 units of apples. And if they only produce pantyhose, they can produce 150 units of pantyhose. So we see that both of these countries, if they only dedicated all of their resources to pantyhose production, that they would both produce the same amount of pantyhose. But if they only dedicate all their resources to producing apples, we see that Krugmania can produce more apples than Welsia. That's a different kind of advantage that I'll talk about in a second. So assuming constant opportunity cost, which means what in terms of how the production possibility frontier looks? Constant opportunity cost. It's just a straight line. Just a straight line. That's it. The opportunity cost is not increasing, it's constant. So if you're being told that the production possibility frontier you need to think about has constant opportunity costs, then you know that it's just a line. So let's first graph these two production possibility frontiers. Again, Krugmania. So in this case, we'll put apples on the y-axis and pantyhose on the x-axis. If Krugmania only produced apples, it would produce 100. If it only produced pantyhose, it would produce 150. Again, those are the intercepts for the production possibility frontier. And for Welsia, if it only produced apples, it would produce 300. And if it only produced pantyhose, it would produce 150. So again, those are the intercepts. And we assume constant opportunity costs, so they're both straight lines. So eyeballing the graphs allows us to assess which country has another sort of advantage that I mentioned a second ago, and that's an absolute advantage. So a country has this absolute advantage in producing a good or service if the country can produce more output per worker than other countries. Likewise, an individual has an absolute advantage in producing a good or service if he or she is better at producing it than other people. And how we can identify that Welsia is better at producing apples, just the very fact that its y-intercept is bigger tells us that. But what that basically means is that if Welsia and Krugmania both dedicate all of their productive resources to just producing apples, Krugmania can produce more. That means that they're better at producing apples overall. That's what it means. So they have an absolute advantage in producing apples. Is there an absolute advantage here in producing pantyhose? No, right? They can both produce 150 if they dedicate all of their productive resources to just pantyhose. So neither of them have an absolute advantage in producing pantyhose. So we can determine which country has an absolute advantage again by looking at the intercept points on the PPF graph. And again, we just did that, so I won't go through it. So in this case, Wellsia has an absolute advantage in producing apples because 300 is greater than 100. All right. Similarly, neither country has an absolute advantage in producing pantyhose because 150 equals 150. I already said that. So we'll determine which country has a comparative advantage now in producing each good. In order to do that, we need to figure out opportunity costs. So we're going to use the same method we use with the production possibility frontier because, well, we're dealing with two production possibility frontiers. So we're going to figure out first, let's say, what Krugmania's opportunity costs are. So it's apple opportunity costs. So let's say that in order to produce 100 apples, it needs to give up 150 pantyhose. So its opportunity cost in apples is going to be in pantyhose. So as far as that ratio that I talked about, the pantyhose is going to be on the numerator and the amount of apples is going to be on the denominator. So Krugmania's opportunity cost for apples, again, is going to be 150 pantyhose over 100. So in order to produce 100 apples, it needs to give up 150 pantyhose, right? And we can simplify that down by canceling out the 50s. 50 goes into 150 three times. 50 goes into 100 twice. So you got 3 halves, which equals 1.5. And you will be able to use a simple calculator on the exam as well, so don't worry about that. I will allow that. So anyway, the Krugmania's opportunity cost for apple production is going to be 1.5 pantyhose. Now, what's really simple about trying to figure out what the opportunity cost is of the same country in the other good is just that you can just take the reciprocal of the opportunity cost for the other good. So here for the apple opportunity cost, we figured out it was 150 pantyhose over apples. And since the production of pantyhose is going to, I've started looking at the opportunity cost of Wellsia first. So let me do that first, and then I'll talk about the reciprocal. Anyway, so I'm going to continue comparing the opportunity cost of apples, but I'm jumping to Wellsia now, and I'm going to do exactly what I did with Krugmania. So in order to figure out what the opportunity cost is for Wellsia, we need to figure out, well, if it produces 300 apples, how much is it giving up in pantyhose? We know it's 150. So 150 will be on the numerator, and 300 will be on the denominator, and we can simplify that to 1/2. So therefore, Wellsia, its apple opportunity cost is going to be 1/2 a pantyhose, which is kind of strange if you think about it, but that is the opportunity cost for Wellsia of creating apples. So what this means is that Wellsia has the lower opportunity cost in producing apples. So it costs it 1/2 a pantyhose versus 1.5 pantyhose for Krugmania. Having compared the opportunity cost and identifying that Wellsia has the lower opportunity cost in creating apples, we can now say that Wellsia has a comparative advantage in producing apples. And the only way we can say that is by identifying the opportunity cost and identifying who had the lower one. So again, the comparative advantage means that you can produce something at a lower opportunity cost. And that's how you calculate it, as we did. And this is how you get to the conclusion of who has the comparative advantage. So let's do the same thing for pantyhose. So let's talk about Krugmania's opportunity cost for producing pantyhose in terms of apples. So remember, to produce pantyhose, you're giving up apples, so the cost will be in apples. So for Krugmania and for any party, really, this is the reciprocal thing I was talking about earlier. If you want to figure out in this two-good world what the opportunity cost is for the other good an entity, be it a country or individual, can produce. You just take the reciprocal of the opportunity cost for the other good. So we said for Krugmania, the opportunity cost for Apple is measured by the ratio of 150 over 100. Therefore, the opportunity cost for pantyhose is calculated by just taking the reciprocal of that. So it'll be 100 divided by 150. So 100 divided by 150 is 2/3. So the opportunity cost of producing one pair of pantyhose for Krugmania is 2/3 an apple. And then we can do the same thing for Wellesley to figure out what its opportunity cost is for producing pantyhose. We can just take the reciprocal of what its opportunity cost was to produce apples. So to produce apples, it was 150 over 300. So we just flip that, 300 over 150, which equals 2. Somebody said it, very good. So for Wellesley, for the pantyhose opportunity cost for them is 2 apples. So as far as apple production, who has a comparative advantage in producing apples? Krugmania, I'm hearing the right answer. I'm hearing the right answer for the majority of you, which is wonderful. That means you're paying attention. So Krugmania has the comparative advantage in producing pantyhose because it has the lower opportunity cost of production. To produce one pair of pantyhose, it only has to give up 2/3 apples. For Wellesley to produce a pantyhose, it has to give up 2 apples of production. So Krugmania has a lower opportunity cost in producing pantyhose, and Krugmania has the comparative advantage in producing pantyhose. Yes, question? In pantyhose, yeah. Right. And any party, in any case, has a comparative advantage because it has the lower opportunity cost in producing whatever the two goods might be. You just calculate it the way we've been calculating it, and you can figure it out. So this is something that you might want to practice just to kind of get it down. And again, like I've said before, and I'll keep saying in this class, like if you haven't seen stuff like this before, it's obviously going to be very foreign to you. And the way to learn foreign stuff is by like repetition, going through it, making sure that once it's been covered in the class that you spend some time to get it, like really get it yourself. You may not know it. You may not walk away like knowing it backwards and forwards for the exam, but if you get it early on before you compound the amount of stuff you need to get, when you are, at the threshold of an exam, you only have to kind of review and remember what you already understood rather than trying to learn all this stuff at once, because although it's simple, and if you take enough time, you all are fully capable of figuring it out, you might have 15 of these different weird things that you've never seen before that you have to understand, and then that is where the challenge comes in, and that's where it becomes, difficult. So again, in a class like this, it's like very technical and the information is foreign, not necessarily intuitive. You want to keep up with the stuff. You want to learn the stuff as you're going along. Take however much time you need to at home to really get it, and then keep moving forward. All right, so we've determined which producer has the comparative advantage in each good. Next, we need to consider how Krugmania and Wellesley can benefit from the situation where they have different opportunity costs. So let's say that without trade, so now we're just imposing what consumption may be. We're not trying to say, well, given everything that we've talked about, they're going to consume this much. We're just going to assume that that Krugmania consumes 50 apples. That's just the preferences of their population. They consume 50 apples and they consume 75 pantyhose, let's say. And this is without trade, so they're not trading yet. They're just based on what they can produce and their own production possibility frontier. That's what they're consuming. Again, 50 apples and 75 pantyhose. Similarly, without trade, Wellesley can consume 150 apples and 75 pantyhose. So having different opportunity costs, again, means that countries can benefit from specialization in trade. If there is comparative advantage, that means that gains from trade can be had. So again, we know that Krugmania has a lower opportunity cost in producing pantyhose, so it has the comparative advantage in producing pantyhose. So Krugmania should specialize in pantyhose production because it has the comparative advantage. Wellesley has a lower opportunity cost in producing apples, so it should only focus on producing apples. It should specialize in apple production. So, and then once they both specialize, then they should both trade in order for each to have some of both goods. Because obviously, if they don't trade, they'll only wind up with the one good they have a comparative advantage in, which is silly because the whole point of taking advantage of their comparative advantage is to gain from trading with others. All right, so in order for both countries to voluntarily trade with each other, the trade has to benefit them both. So the next step is for countries to decide on the trading price. So since Wellesley can produce apples at a cost of half a pantyhose per apple, we know that it will want to receive at least half a pantyhose for each apple it trades with Krugmania. If it gets less than half a pantyhose, then it won't want to trade, because then for it, like if it were to produce one apple, then it would only have to give up half a pantyhose. So that's its cost. So it at least wants its cost covered, or if not, it's not going to trade. So again, it wants to cover its cost of production. Of course, it will gladly accept more than half a pantyhose for each apple they send to Krugmania, but half a pantyhose can be treated as the lowest price it'll accept for each apple. Meanwhile, Krugmania is happy to buy apples from Wellesley as long as doing so is a bargain. So we know that Krugmania can always produce its own apples at a per apple cost of 1.5 pantyhose. So Krugmania would be happy if it can receive apples from Wellesley for a trading price below 1.5 pantyhose per apple. So we've established a lower and an upper limit for what one apple will likely trade for, either 1/2 a pantyhose or at most 1.5 pantyhose. So Krugmania, again, will pay up to 1.5 pantyhose per apple, and Wellesley will not take anything less than half a pantyhose per apple. So this range is what's called the terms of trade, the price range that makes trade mutually beneficial. So in this case, it's above half a pantyhose and below 1.5 pantyhose per apple. I should have said pantyhose, not fish there. Sorry about that. Would a price of one pantyhose for one apple make both Wellesley and Krugmania willing to trade? 1 for 1? Why is that? So no, just remember, like these are upper and lower bounds for the terms of trade. They're willing to trade for a minimum of 1/2 pantyhose, but at most 1.5 pantyhose. What if they decide, well, let's just trade 1 for 1? Wouldn't that fall within the range? It would, right? So then it would satisfy the terms of trade, and they would be willing to trade pantyhose and apples 1 for 1. Again, yes, it is in the range of prices that are mutually advantageous. So let's see what happens with consumption when the countries specialize in trade. So again, here is the two countries. We've got consumption without trade. This is where we started from. And then we're going to go to consumption with trade. So both points we should first note are outside the production possibility frontier, which in a situation where they're not trading would not be possible. It would not be feasible. Those are points of production that are not feasible. So the figure shows an example of this scenario where the two have specialized and have decided to trade 75 apples for 75 pantyhose. So again, we said that Krugmania is going to focus on, so specializing Krugmania produces 150 pantyhose, and Wellesley produces 300 apples, so that's where they're starting from. So trading 75 apples for 75 pantyhose means that Wellesley will have 225 apples to consume, which increases its apple consumption by 75. So that's more than it was consuming before of 150. So because they focus on their comparative advantage, they produced 300, they gave up 75 to Krugmania to get 75 pantyhose, and they wound up with 225 apples, which is more than they had before trading. Similarly, Krugmania increased its apple consumption by 25. So before, Krugmania was consuming 50 apples, but then because it took advantage of its comparative advantage, it produced 100 apples. And where was I? Let me see. I think I'm off here. So wait. So all right. So similarly, Krugmania increases apple consumption by 25. Oh yes, of course. Okay, so Krugmania is producing pantyhose, right? So they produce 150, they give up 75 pantyhose, they get 75 apples, which is more than 25 more than the 50 they had before. So comparative advantage exploited has led to what are gains from trade. The gains from trade are both countries being able to consume more of both goods than they were able to produce individually before when they tried to produce everything themselves. So this is where the power of the production possibility frontier and the comparative advantage model becomes clear, where it just highlights like this advantage of specializing in what you have the lowest cost in, having the comparative advantage in, and how that can benefit everybody, and why trade, therefore, amongst nations is important, because it leads to these kind of results. So when you hear about Brexit and Britain trying to leave the European Union, they have a bunch of trade pacts that, say, well, we're going to produce this and you're going to produce this, and we're not going to have like all sorts of barriers to trade, so it's going to be easy for us to trade. And because of that, everybody benefits a lot, and there's a lot more produced in the European Union than if countries were to just try to produce everything themselves. But then you have people within the country that don't like trade, because generally you'll have like, wealthy parties that like aren't actually benefiting because maybe their particular industry is hurting because of trade. And so then they try to sort of shift the conversation in a way that's going to make things seem unfair for, more people than it actually is unfair for. And then that's going to change public opinion. And then people are going to go to the polls and they're going to vote to exit a union, which is what happened. And it's unfortunate. And it's who knows? Nobody knows what's going to happen at this point. It's so uncertain. Like nobody knows, and it's going to take years for them to get out of the union. And so we're not even going to see what's going to happen for a few years, and it's just ridiculous. The whole thing is absurd. All right. Anyway, let's finish this off quickly with the circular flow model, and then we will take a break. This shouldn't take too long. So let's now consider our third and final model for this section, the circular flow diagram. The model illustrates the flow of money, goods, and services throughout the economy. So the figure shows a simple circular flow diagram with only two groups, households and firms. Households consist of either individuals or groups of people, usually, but not necessarily a family, that share their income. A firm is an organization, usually but not necessarily a corporation, that produces goods and services for sale and that employs members of households. So firms and households interact in two kinds of markets in this simplified world. There's a few other markets that they interact in the more realistic version of this, but again, we're talking simple here. So the two markets that they interact in are called the market for goods and services and the factor markets. So in the market for goods and services, households buy goods and services they want from firms, right? So households buy stuff that's produced by firms. And in the factor markets, firms buy the factors of production from households. So they buy labor and they buy maybe like the capital that households might own. So transactions in the markets for goods and services produces a flow of goods and services to households and a return flow of money to firms, right? People buy the goods and then they pay for the money. They pay for the goods with money, which then goes to firms. So goods and services go in this direction and then money goes in the opposite direction. Transactions in the factor markets is comprised of firms buying the resources that households sell. So again, households have labor to sell, and they also own things that firms can use to produce, such as factories and other factors of production. So households provide factors of production in the factor markets. Firms buy those from the households, and then they pay money into the factor markets, which then goes into the households. Partly, this highlights like that one of the principles that we covered last time towards the end, one of the macro ones, that everybody's spending is somebody's income, and therefore like the money kind of just comes around, and that's what's highlighted here. Like the money spent by firms on the factors of production go into the household's pockets, which then spend on goods and services, which then becomes income for the firms. So trade in physical things such as goods and service, labor, and raw materials flow in one direction. So we've got goods and services, factors, goods and services. So that's going in one direction. And then money that pays for these physical things flows in the opposite direction. Money comes from households to this market here, goes into the pockets of firms, which then goes into this market here, which goes into the pocket of households. So the circular flow diagram is, in the interest of simplicity, ignores a number of real-world complications. In the real world, the distinction between firms and households isn't always that clear-cut. Obviously, people that have homes also own businesses. So consider a small family-run business, a farm, a shop, a small hotel. So a more complete picture would include separate boxes for family businesses. Many of the sales firms make are not to households, but to other firms, right? So one firm maybe makes an engine for a car that sells that engine to the car to the final manufacturer of the car in order to then sell the car in the goods and services market. And steel companies sell mainly to other companies, such as auto manufacturers, not to households. A more complete picture would include these flows of goods and services and money within the business sector. So the figure also doesn't show the government, which in the real world diverts a lot of the money out of the circular flow, in the form of taxes. But it also does inject money back in the form of some sort of spending, either directly or indirectly, putting money in people's pockets, or spending money on services that then does put money in people's pockets. Despite the simplicity of the circular diagram we just saw, which we'll see more complicated versions of later in the semester, the circular flow diagram is very useful as an aid to thinking about the economy. And just a couple of last words on using models in general. We've learned that economics is mainly a matter of creating models that draw on a set of basic principles that add some more specific assumptions that allow the modeler to then apply those principles to particular situations. So what's left to explain is what economists actually do with the models. Economic analysis has two key roles. Analysis that tries to answer questions about the way the world works, which have definite or wrong answers, is known as positive economics. In contrast, analysis that involves saying how the world should work is known as normative economics. And you can extract the meaning from just the words by thinking of like normative is kind of having the word normal in there, which the idea of normal is relative. Like what is normal to you may be different from what is normal to me. So normative economics is sort of captures that subjectivity where, the whoever's trying to practice this kind of economics is trying to impose like their own idea of what is normal or good or whatever onto whatever it is they're doing, versus somebody who's working in positive economics that's basically just saying, this is how things work based on my observations. And then people can say whether that's good or bad, etc., outside of the analysis. So positive economics is about description. Normative economics is about prescription. Positive economics occupies most of the time and effort of the economics profession. Models play a crucial role in almost all of positive economics. The distinction between prescription and prediction is important as well. Positive economics often use models that explain an aspect of the economy and is used to attempt to predict what the economy will do via like a forecast. A forecast is a simple prediction of the future. Forecasts may seem like prescriptions sometimes, since they tell you what will happen if a policy were changed, but they don't tell you whether or not that result is good or not. So you can say, well, based on what's happening in the economy, we project that wages are going to go up by a certain amount, and that may or may not be wrong, but the person making that forecast isn't saying, and that's a terrible thing, and we should change it. Like, that's not what they do. We leave politicians to do that, or pundits, or whomever. Economists often do engage in normative economics, though, and do give policy advice. Economists are also citizens with opinions. We're people, so you're going to get that. Economists have a reputation for disagreeing as well. Media coverage tends to exaggerate the real differences in views amongst economists. Disagreements are generally more exciting, so obviously they get attention, but the more common agreements are not exciting and almost get no attention. So you hear about economists disagreeing, but you don't hear about them agreeing, which happens a lot more often. Economics is often tied up in politics because economists are often advising politicians. Powerful interest groups find and promote economists who profess supportive opinions. Economic modeling requires simplifying assumptions. Two economists can legitimately disagree about which simplifications are appropriate. In most cases, such disputes are eventually resolved, but it can take a long time before research settles into important disputes. The important point is that economic analysis is a method, not a set of conclusions. And again, that's what's important about this class, is to learn the methods, understand how they work, understand maybe the conclusions we get to, and understand the nature of those conclusions with respect to the assumptions that we made, and also understand that we are transparent about the fact that it's not perfect, but it's the best we can do given what we have to deal with. All right, folks, let's take 20 minutes. We'll come back at 8:40, and then we will cover chapter 3.